Hello everyone. Thank you for joining me. I'm Rahul Pingale from Walquest. I'm a technical director at Walquest. Today I'll be sharing how material engineering, specifically in wall coverings and non-woven substrate, plays a direct role in advancing IoT connectivity, robotics, sustainable building, material system. This presentation is about how we turn something as ordinary as wall into active part of smart environment. Let's start by looking at why our current infrastructure isn't keeping up with today's connected world. Traditional building materials, especially vinyl wall coverings, faced a challenge for smart buildings. They often emit VOC, block the wireless signals, and are difficult to replace when sensors or automation systems needs upgrades. This means our physical space are holding back digital progress. To overcome this, we need a new generation of material. Surface that don't just decorate the wall, but actively enables connectivity and automation. Our team engineered three key breakthrough that makes this possible. Let's see what are those three breakthrough. So these three breakthrough, one is nano barrier coatings, a Microsphere PSA technology, and multi-method printability gives us the better digitally enabled space. So microsphere coatings for superior moisture protection. Microsphere system is for responsible clean installation. A multi-method printability allowing us use of gravure, digital, flexo printing methods. Together, these form a sustainable IoT-ready surface platform. Smart environments need surface material that interact, not just insulate or decorate. They must support embedded sensors, RFID systems, and QR code automation while being safe, recycle, and easy to remove or replace. Essentially, the wall itself becomes part of the IoT ecosystem. Let's take a closer look at each of these technology, starting with the nano barrier coatings. Our water-based nano barrier coating replace solvent-based vinyl-based coatings while matching their durability. It's validated to ASTM 96 with a moisture vapor transmission, outperforming most non-ovens under high humidity. And because it's a zero solvent, there are no VOC emissions or disposable issue, making it safer for both manufacturing and occupants. Let's now see that we have solved the barrier challenge. It look at how we tackle the adhesion. The conventional adhesive form the permanent bonds that makes removal destructive. Our microsphere pressure sensitive adhesive technology creates a tiny contact points instead of a solid layer, gives high strength while still allowing full removal without damage. This means sensors, wall panels, or digital display can be repositioned or replaced without surface repairs. It's ideal for IoT-enabled buildings that evolves over time. Next come most exciting part, how these materials enable printing, coding, and sensing directly onto the surface. We design the substrate to work seamlessly with the inkjet flexography and UV digital technology system. That means we can print RFID antennas, QR codes, conductive inks traces directly onto the surface. This allows the wall itself to communicate, acting as a layer for automation and robotics. And this brings us to how this material integrate into the IoT and robotics ecosystem. The smart walls enables three things: wireless transparency, maintaining a signal strength for robotics and sensors. Embedded sensors such as temperature, occupancy detector are built right into the wall. Machine readable markers like QR codes, NFC chips that guides autonomous navigation. In short, surface become the communication fabric for connected spaces. But innovation only matters if it is meets safety, sustainability standards. Let's look at our compliance. Our platform meets strong VOC emission testing like CDPS 01350 for ultra low VOC ASTM 84 Class A fire safety and complies with the REACH and well building standards. It's free from pathlate, halogen, heavy metals. This ensures smart doesn't come at the cost of health and environment. We validated all this through independent standard-based testing. Every compliance property needs barrier, adhesion, fire, VOC performance, and is verified through ASTM and FINAT testing. We even simulate 5-year durability to ensure stability across different climates. This data-driven validation builds trust, especially in sectors like healthcare, education, where compliance is critical. And those are the exactly market where we have already seen the strong adoption. So we adopted this platform in over more than 15 facilities across North America and Europe. In hospitals, it supports infection control and integrates with the automation system. In schools, it allows flexible, low-emission learning space. And in smart offices, it enhances connectivity for IoT analytics. This proves the technology is ready and not just a theoretical. So, what does this mean for robotics and connected environments? So, for robotics, this smart non-owned surface serves as a navigation map, data networks, compliant infrastructure, all at once. They support RF transparency, embedded sensing, asset tracking, and damage-free updates. Everything connected space needs for autonomous systems. And to scale this across industries, structured adoption approach is the key. So we developed a 4-step framework for implementation. First, align material capability with automation needs. Second, engage facility, IT, and sustainability team early. Then third, run small-scale pilot trials to validate the results. And fourth, use the data to scalable the trials efficiently. This approach ensures every deployment is both technically and operationally successful. Now, to wrap this up, let's summarize key lessons from this work. First, smart material means smart infrastructure. They enable IoT and robotics, not just decorative walls. Second, data-driven validation builds confidence for large-scale use. Third, multifunctional design reduces cost and simplifies the procurement. And finally, real-world adoption shows this technology isn't futuristic, it's happening right now. So how do we carry this momentum forward? The future of connected environments depends on material innovations. Smart non-owned surface from foundation of intelligent buildings enable wireless communications, embedded sensors, and sustainable compliance that older material can't catch or can match. In short, material engineering is infrastructure engineering for connected edges. I hope this session gives you a new perspective on how material science connects with robotics and automation's sustainability. Thank you for your time and attention.